Hi. Okay, you can hear me quite all right. So, hello everyone. My name is Aisha Bello. I work for Cisco as in a small team called Global Virtual Engineering, and I work as a virtual systems engineer um, in the data center and virtualization practice. And today, I'm going to talk about spine on my network for a day. So, the networking world, as I like to call it, I just started in like 10 months. So I was trying to like look for a way to combine my love or my first love, which is, data science and data analysis with, networking, which is like a different domain altogether. To start with, do we all get this kind of questions where someone is like, my network is slow, I have no idea what's going on. I mean, sometimes my phone is backing up through an upload bandwidth, which sometimes is like 1/10 of the actual download bandwidth. Or maybe my neighbor knows my password now and is doing things that I should be aware of. Or, I mean, it could be like the line or the fiber to home line, it's bad. Or maybe the NSA is spying on me. Who knows, right? So we're bugged with these kind of questions. We don't know what's going on in our network. And sometimes it helps to be curious, to know, what's going on. Like, how do I know what's going on? So I had a lot of questions. How do I know what's taking up all my network bandwidth? How how can I tell what's going on in my network? Because sometimes, like where I come from in Nigeria, we don't have fiber to home. What we usually have is modem, and you pre-buy your data. So you buy like 2 gig of data, and you probably, I'm like, one day I'm back home, and all of a sudden it's finished. But I'm like, I'm very sure I have not used up to 2 gigabits of data. So what's going on? I mean, if I can tell what's taking up my network bandwidth, I mean, I can detect if it's my neighbor or maybe it's me and I'm not just aware of the fact that my computer is using up a lot of bandwidth or data. So in trying to do this experience, I'm asking myself questions along the way. I'm like, okay, now I know what I want to do. So how do I capture my own data? What's the best way to do this? And usually, when you know how much data that you capture or how much data that you use, you can basically plan. So most of you are like machine learning experts, and let's say, for example, you want to learn about your network. You want to take a snapshot over 1 week, and you want to learn. And so you know a snapshot. You have your behavioral pattern. Your network is telling you what your behavioral pattern is. And when you divert from that pattern, you can set up alarms and say, okay, this is a weird website or this is a weird MAC address, like what's going on. So basically around planning, so I know how much data I need. I can plan for the storage. I can plan that, okay, if every day I use 2 gigabits of data and I want to learn about my network in 1 week, I should probably plan for like a 14 sort of gigabits like in my hard drive. Just as an example, which answers the question, where would I store it, right? And so in this experiment, I was like, okay, I want to try and be, unbiased, and I'm like, okay, when is the best time for me to collect this data? Should it be when I'm at work? Should it be when I'm at home? Because I have two computers anyways. Like, I'm using one for work and one for, I'm using one personal. So when is the best time to actually collect this data? And now that I have it, how do I go about analyzing it? Going on a bit to the experimentation setup. So this was basically what I use, Windows. Yay, anyone excited for me? And my router at home is the download speed is there, and the machine I use is the Lenovo. And for the experiments, I use Wireshark. I use visualization I use Wireshark to analyze and capture the network traffic, and I used Bokeh to visualize the data using Jupyter, a Python notebook. So I need to give you all a warning. If you're going to do this, if you're like me and you share an apartment with 3 other people, you should maybe ask their permission, right, before trying to capture the entire packet flow. Because I have like 2 flatmates, and usually they're not so excited about that. No one ever is, right? But yeah, if you're at home, you could like, and you pay your bills, like you have your internet, you're not sharing anyone, you can easily capture your data. So before I go into answering these questions, let's do some network 101. Like we need to understand, before you go into any data project, you want to have a bit of domain knowledge about what it is it's going on. what it is you're looking at. The IP packets. So I'm just going to maybe not go through a lot of these things, but go on to what I think is very important for like the duration of the talk. I think the first one is the version, and you would say that now we're moving from that point where IP addresses are like, then when the IP version 4 came out, no one knew how the internet will boom. Like no one knew how nowadays we have our mobile devices and they all need IP addresses. So we've moved on to version 6, but this part of the IP packet tells you what version of the IP you're using and the type of service. So more than just collecting your data, the idea is that when you can do analysis, you can make informed decisions. You can learn something and you can make informed decisions. And usually, there are different types of packets. There is me on my Google Hangout saying, hello, buddy, and the other guy at the other end of the line is receiving the message. But then again, the way that my data packet should be treated shouldn't be the same way my voice packet is treated, because voice is very sensitive, right? So there shouldn't be like a time lag from when you say hello to when the other person receives it. So there is like sensitivity, and there are different ways you can handle your packets. And those kind of ways are enforced by using this part of the header. Total length is basically the entire size of your packet. So this is not just the headers. It also includes like what's the size of the data. But now there is a limit, because for every hello you send, it's probably broken down into 10 different packets, and it's routed like over different routers in the internet to get to where you are, wherever you are. Which brings me to fragment offset, which says, okay, I have 10 different packets that will probably take different roads to the same destination, right? So how do I assemble them back together? And this fragment offset tells you it's packet 1 or 2 or 3, and that way it assembles them when it gets to the destination. Time to live is a way so that if I say I want to send Aisha Bello an email and I miss an I in email address, and for some reason it's wrong, right? But you've already sent that message. So time to live is a way to ensure that, if your packet has the time to live reduces and gets to 0, the router knows to discard the packet so that it doesn't keep going around network trying to look for a destination that doesn't exist. And now, the concept of addressing is, if you want to send me a package and I live in Prague currently, you would probably know my address as number 5 Brill Avenue, but that's my IP address, right? How do you get access to me? Okay, I stay in flat 4. Okay, that's my MAC address. But how do you get to me? I have flatmates, so how do you get to me? You need to know, or sometimes you know my room. So the network is like that. You need to know exactly, not just your MAC address, not just your device, but it needs to know the port. It needs to know which application specifically, so that when I send my message from Google Hangout, it obviously cannot go to Skype. Like there is a port number. And so that's the whole concept of addressing. And moving on, just going on to say, usually there's a stack. And as data moves down the stack, there's an encapsulation that goes on with the header information. And as it moves up to get to you, it's de-encapsulated. The headers are stripped off until it gets to you and gets to the specific application. So let's just say that your packet is a mixture of your actual data, your transport information, your header information, and a lot of other things to make sure that it gets to its destination. So enough said. Let's get to the interesting part, right? So how much data do I generate on a daily basis so that I can plan? Like, I want to take it further. I want to have an idea over a period of time how much I collect so that I can plan ahead in terms of capacity, because it's a problem, but there are many different ways to solve them. So I have 2 laptops. I have 2 computers, rather. I'm at work, and I spend 9 hours of my day on my work computer, and maybe the rest, I'm already tired, 2 hours, I do a couple of mails and I go to bed. So how much data do I actually generate on a daily basis? Now, the experiment was me analyzing my personal computer traffic, not necessarily my work data, but I wanted to have an idea of how much data I was using in a day. And this is an example, but this is a typical day where nothing spectacular was happening. I wasn't having video calls or, doing all this other things. So this was one of those days in the week where things are slow, nothing major. So yes, from there you can plan, for example, in retrospect, how much data do I consume, and you can plan like, okay, I want to learn about the behavior, the characteristics of my network over a couple of weeks or months, and you can plan effectively. So my packet flow for a day. So this was like the entire day, and I was just trying to see, okay, what's going on? Like, where are the spikes in the in my network? At what times am I using the most bandwidth? But what's interesting to know is that for every second, packets are not necessarily leaving your computer every second. In a second, you might release, like your computer or your machine can release up to like some 30 to 50 different packets from different angles, different sources, even services you're not aware of. So, as a snapshot, this is more like an aggregation of the time on a per second level, and in a second, which could be as many as 20 different packets, like how much bandwidth was consumed at that point in time. And you can make some assumptions and say, oh, okay, at this point, it's the small dotted, at that low point, there's someone looking for an IP address, someone just came home, or there's an address resolution that wants to go on. So many different things that you could infer from this, but the power is not the power is more in the visualization. It's how that you can have all of this information and you can visualize it. Just by visualizing it, you can make some make some inference, and you can make decisions at the end of the day. So I am zooming into the first 300 seconds, which was like an aggregate. So how much bytes was I consuming? I wanted to know what exactly was going on. Like, there is an average, right? So maybe at this point of where the aggregate is 5,000, maybe I was watching a YouTube video or something. But why is there this like huge spike all of a sudden, and that happens at one moment? And sometimes you can, even from a security standpoint, you don't know what happens when you're not with your computer, right? So even without you doing anything, there's so much information that your device gives out. It's always like sending information, services that you're not even aware of. So from a security angle, you can make an analysis based on like on the visualization and say, okay, if something of this nature happens, send me an alarm, then maybe you could go on and investigate at a later point. So I just wanted to show here what the packet capture is like. There's so much information. So apart from having like the source or the destination, addresses that it uses, you can see like, so this is Wireshark, in case I didn't mention that before. So you can see how much bytes you're consuming. Obviously, this is not a lot of bytes. This is, oh, okay, there's an application data, then okay, probably an acknowledgement is going on. What I think I wanted to emphasize here at this point is that there's so much going on. There's an address resolution going on. There is TCP acknowledgements going on. But then there's like, when you drill down into the packet, you know what it is specifically. Like if you use like the arrows there, you go in, you see a lot more information. But what I wanted to do was, like, really, how much of my bandwidth am I using for what specific purpose? So I did like some sort of visualization to see what this was. So it might not be like a it's not a, yeah, it's normal, right? Majority of your bandwidth will probably go to YouTube videos, or it will go to some other kind of videos. But is using statistics, you can tell what's going on. And even in UDP, there's so many things that use UDP. So it's not only videos. You can see other things using UDP, like the quick UDP internet connections. Sometimes even your voice packets use UDP instead, like because they need to go fast. They don't need the extra baggage that comes with a TCP packet, and they just you care about is speed. You don't care about whether it's delivered or not. So different protocols for different purposes. And so this is just like a statistics of what and what specifically was consuming what at what, like, so the entire capture is, and this is saying what percentage of the capture is doing, is which protocol. But there is a lot of information that you can deduce from here. And I'm sitting there trying to understand, okay, what is quick UDP internet connections? What's going on? Like what is this? Is this just YouTube? Like, how much YouTube did I use to begin with? Then what happens? Veronica comes home. Hey, I'm home. I'm like, I know you're home. Like, so from the moment you're within, so Veronica is my flatmate, and the moment before she tells me she's home, I know. I don't know if you see that sometimes this could even be a way to detect burglary. Like, what are the weirdness going on? Like, before you get home, I know you're home, because the RF signal, picks up on your device and says that, okay, this is normal. So I can tell when my mom gets home or when my dad gets home, or I can tell when there is a very weird MAC address going on. And sometimes it's not just passing by. You can detect if somebody's passing by know how long they stayed in a particular place within the area of your signal, as opposed to if they were really in the house and I'm not expecting anyone, and all of a sudden, who is going on? But this is just like, oh, I'm home. I'm like, yeah, I know you're home. I knew before you got home. I already knew you were home. Does anyone know what googlevideo.com is? No? YouTube. I didn't know that. Like, I was like, okay, why? There's YouTube.com. What's Google Video? Okay. then I went on. But the point is that, so this, for example, is a session. It's a session that there was a communication that happened between my client and the server. And the session is basically from when I say, hello, I need something, to when the server replies, and from where those information is sent, when I get what I need, that connection is terminated. So this is like a stream to say, okay, for 37 MB, what exactly was I getting from YouTube? I mean, this is just an example, but there are many ways that you can think about it and you can spin this around. Who knows who this is? Shante. It's me. Remember, that's my nickname. So this is just saying you can get so much information. You can know the device. You can get information even when you get a response from the server. If you're getting from like a website, you can get information about the specific server that is serving you. So there's so much information that you can get basically from analyzing your capture or your packet. So in all, why should you care? Why should you care about what goes on in your home router? Many of us, for example, might be developers, and we do majority of our work at home. So, I mean, if I have work critical applications, right? I need to have my meetings, I need to have my calls. How do I ensure that my son or my daughter is not using this bandwidth for video imaging or game video, and no, it's video playing, like games. That's what they call it, right? Okay. So there's so much motivation that can go to why you should analyze your network. But one of it is there is a lot of data. We generate lots and lots of data, whether we know it or not. There's a lot of things our computers do without realizing it. Like, seriously, there is even more data. Like, every micromilliseconds, you're generating lots and lots of packets. And it can give you, on a broader scale, it can give you insight as to what's going on. For example, the total capture I got was like, my personal capture for that day was 354 thereabout, and that resulted to over 454,000 worth of packets captured to analyze. Just imagine like the volume of information that you have. And this is what organizations use, because nowadays we're seeing malware. We're not seeing malware gone are the days when all you needed was a firewall and you were protected. Now there's so many ways you can get like malwares, from emails to the websites that you're visiting to other things. So by analyzing the packets, you can tell, because once you know the flow of the packet, you know how it should go or what it should look like. You can tell when there's an anomaly, which I think that machine learning at this point is what many people should use or can use to know a lot about their network. You can be your own police using machine learning. There are other ways that you can go about solving this problem. I went the low-level analysis way, but there's so many other ways that you can go about it. And you can be your own police. You can detect if it's your neighbor that has your password. There's a weird MAC address somewhere. You can detect if something, like if there's a service that shouldn't be sending, there's a weird service going on, and you can drill down to see, okay, maybe this might be someone already infiltrated my system and sending information from my computer to their server or their command and control center somewhere. So why would you want to automate the process? So I know the majority of the audience are data scientists or data engineers, and why should you care about automating the process, right? It could be a process of just visualizing your data and hooking up a dashboard, and you can visualize what goes on, how the traffic flows, what is important traffic and what is not important traffic, and you can set policies, little policies like, you know what, Facebook, I'm addicted. I think I'm addicted to Facebook, just as an example. And I can set that, okay, this number or this amount of bandwidth should go to Facebook, like 10 MB, for example. But you can detect intrusions, for example. You can learn, so you can learn over a week, understand your network behavior, your characteristics, get those insights, set policies, or apply the rules, and you can relearn and keep learning. And it becomes really robust because you can detect when something is outside of the normal behavior. You can detect anomalies. You can do this differently. So like I said before, I went like low-level capture, looking at capture, looking at streams of capture, looking at what was important and what was not important. But you can go differently. You can go layer 7. I only want to see how much bandwidth each application is consuming. So it might be Skype, it might be a Hangout, it might be any other application that sends information. But you can think about this differently. You can have a Raspberry Pi and hook it up in the middle to collect all that data and send it to the cloud somewhere, and you have this nice fancy dashboard showing you visuals, and you can set alarms. So there are many ways that you can go around this. And there are other applications, there are other open source tools that you can use to analyze your traffic, like Snot, like Scapy, I'm not sure how it's pronounced, but Scapy, you know what I mean, or Moloch, because there are so many ways that you can go about it. And mine was, I get this capture, I filter the important information I want from Wireshark, and then I export it as a CSV, and I visualize it using Bokeh. But there are frameworks that specific for packet captures. And maybe there are other ideas that I have not even thought about that you're probably already thinking about. Or some people can, or like, if you like to hack, you can hack your router firmware using OpenWRT. I've seen it. I personally would not, because I really don't want to mess. What I want when I get home is I want internet. I don't want to mess with that process, right? So it could be something you're interested in, but there are just many different ways that you can go about doing this, which I wanted to highlight. So what did I learn about myself after all of this? that I am addicted to this blog called Stella's blog. I should probably reduce the number of times and the number of time I spend on the blog. Note to self, we're all constantly learning about ourselves every day. For anyone else, it could be Facebook, it could be Twitter, but mine is this specific blog. I need to, watch it and be more productive. Or, I'm using Windows and there's just so many services I don't need that happens. Like, I don't want it and you're taking up my bandwidth. You can disable, you can know which of these services are sending traffic, and you can actively go and disable the ones that you don't need. Like, I don't need the weather report on my computer. I have my phone for that. There's so many ways, things that you can discover. Just as an example, well, I can tell when my mom gets home, or when I have visitors, or when maybe it's just a burglar. Thank you. Any questions? Yay, no questions. Okay. Really? I must have done a good job.
Hi. Thank you for the talk. Would you mind going over the example where you can see that someone got a home? I think that just went by quite fast, and I didn't.
Oh, okay.
Yeah.
You want me to go back to this slide?
As in, like, explain how you could tell someone got home?
So it was, so the thing is, when you're within like a place where you have an RF signal or Wi-Fi, your phone, especially when it's on, it tries to connect. So it's doing a lot of hello, hello, I'm here, I need an IP address, hello, hello. So in my case, that's what happened. And I knew she was home because she was sending DHCP requests and screaming, I need an IP address, I need an IP address. And from the MAC address, you can tell specifically, which device it is. And, she has a name on the iPhone that, and you can tell from that basically by the broadcast of packets and saying, I need like a DHCP request. Like, that's what I was going to say, yeah. Thank you for your question.
I'm just curious if you did or if you thought about doing an experience where you are using a software, for instance, you're using your favorite IDE to develop code, and you don't do anything else, and you just want to figure out whether that software, which might be closed, is sending stuff to someone that you are not aware of it. I think that will be one interesting thing to explore with all that, what you set up. Thanks.
Yeah, that's true. But is that a question or?
Kind of a suggestion
question.
Right, great, if you did it or not. Or
yes,
if you
yes. Didn't. Oh, okay, yes.
Because I noticed one thing that you discovered was that service weather from Microsoft, right?
Yeah, there's so many services. That was just an example, one of the many
things.
I
believe most of the software that we use daily is sending those stuff that we are not even aware of.
Yeah. That's true. It's very true. Thank you.
Hi.
Hi.
Are you worried about your neighbors being able to tell when you're home or not?
That's a very good question. Yes, I'm worried. Yes, I would say I'm worried, but yeah, I guess they could tell if they had my password and could do like a monitoring. I mean, maybe this should be an example. Put some rules so that no one can do packet capture on your router at home. Thank you for that. And I should maybe go home and do that.
Hi, thanks for the talk. Could you tell us a bit about the precautions you've taken maybe in the past year, or any new practices, any advice?
Based on this?
Yeah. Since you're worried about your neighbors knowing about your life, then.
So this project I did within a space of 1 month, so it wasn't like over like a long period of time. But the idea is that if I know what applications, or if I know where the most of my bandwidth goes, I can mitigate against how much time I spend there, or what people can do when I'm not looking. So I don't know if that answered your question, but did that answer your question? Yeah? Okay.